Okay, this is your practice test for tomorrow's retest on Chapter 5, adding and subtracting polynomials. Your first 6 questions are true or false, and the first 6 are true or false. The first one says an expression, or the monomial 3xy squared has a degree of 3. The answer is true. And the reason why we know this is the degree of a term is determined by the sum of the exponents on the variables within that term. Since 1 plus 2 is 3, 3xy squared has a degree of 3. Question 2, when I combine this term with this binomial, the result will be a binomial. So if I take this term and I add it to or combine it with this term, will I get a binomial? Well, when I look at this, combining is the same thing as adding, which is the same thing as gathering like terms. And if I look at my x squared or x cubes, I have this one and I have this one. When I combine those two, we know from experience those are algebraic zero pairs, which results in a cancellation of 0, leaving me with just positive 2x as an answer, which means it's false. It ends up being a monomial, not a binomial. Question 3 says this binomial is equivalent to this massive polynomial. In order to solve this, what we have to do is take this massive polynomial and gather like terms to see if it actually simplifies down to a binomial. We're going to gather our x squareds first. I have 2x squared, negative 1x squared, positive x squared. That makes a negative 2x squared when I gather it. A positive 4x stays by itself, and these two will become negative 3. Since these two expressions are not the same, my answer is therefore false. Question 4, the sum of these two polynomials will result in a monomial. Gather like terms. These two terms are like terms, but when I gather them, did I miss something? Sorry, I made a mistake here. These two should have made a negative x. But still, it's still false. They're not equal. In question 4, these two that I canceled out are zero pairs, algebraically speaking. I'm left with a positive 1 and a positive 1, which makes it 2. So the sum of these two is a monomial. The answer is true. The monomial of 2 is still a monomial, even though it doesn't have a variable. Okay. Question 5, when x is negative 1. So when we do this, substitute negative 1 for your x value. So this x became negative 1. Simplify using BEDMAS. Negative 1 squared is positive 1. Negative 3 times 1 is negative 3. And negative 3, take away 1, when I solve that, is negative 4. So this side here, when x is negative 1, will simplify down to negative 4. When x is negative 1 over here, negative 5 times negative 1 is a positive 5. And a positive 5 take away 6 is negative 1. Is negative 4 greater than negative 1? No. Therefore, the answer is flays, or false. Question 6, the sum of the algebraic expression and its opposite is 1. The answer is false. We know this because on our test, we know that the sum of an algebraic expression and an opposite is 0. Right? And we can give an example if we wanted to. Example, negative 2x, the sum and its opposite. These two together don't make 1. They make 0. Question 7, rearrange the polynomial in descending degree. So I have 1, 2, 3, 4, 5 terms. The one with the highest degree is this one right here, because it has a degree of 4. So I am going to write negative x squared y squared as my first term. I'll put a line through it to make sure I finished it. My next one is this one here, which is a degree of 3, minus 6xyz. I'm not putting commas, I'm just rearranging it in descending degree. Then I'm going to put this one, because it has a degree of 2, minus 5x squared. Then this one, positive 6y. And finally, my constant, which has no degree, will be a positive 2. So when I rearrange that 5-term polynomial in descending degree, that's how I should properly write it. Question 8, same thing, gathering like terms here. Start with your highest degree term of the, let me just get a highlighter here, of the 1, 2, 3, 4, 5, 6 terms that I have. The highest degree term is my x squared. Guys, if you wouldn't mind not talking when I'm teaching. Thank you. That becomes x squared. These three terms are like terms. Negative 3x, and positive 9x. What will those become if you combine them? Positive 3x. And our last one, the constants of negative 1 and positive 1. Alexis, if you combine a positive 1 and a negative 1, what do you get? Nothing. So therefore, it will not be that. When you combine them, you end up with that binomial. Moving along quickly. Question 9. Gather like terms. We're going to start with our x squareds. This term and this term, when I combine them, I really keep my x squares and just combine the coefficients. Positive 7 and negative 5. So if I combine the negative 5 and the positive 7, I end up with a positive 2 coefficient. Those are done. When I combine those two like terms, I get 2x squared. My next ones are my x's. A negative 2x and a positive 1x make a negative 1x, or more properly speaking, just negative x. Those are done. And finally, when you combine the constants of a positive 12 and a negative 11 and a positive 1, these two make positive 13. Altogether, you would have a negative 2. Question 10 says find the sum. You could also say add. You could also say simplify. You could also say gather like terms. They all mean the same thing. So with this binomial and this binomial, the like terms would be a negative x and a positive x. And if you're having difficulty, sometimes it helps to kind of think of it as a picture. And we know that when we combine those two, they're algebraic zero pairs, which means they make nothing. And a negative 4 and a positive 5 would mean the sum of those two, that binomial plus that binomial, ends up being just the number 1. When we add this binomial to this binomial, we have to first consider what of the four terms that are in those collectively, which one has the greatest degree. It's the negative 5x squared, but since there are no other x squared tiles or x squared terms, we're just going to keep that as is. A positive 5x and a negative 8x. Keep the term, combine the coefficients of positive 5 and a negative 8, make a negative 3. So that's our second term. And the 9 is just a constant, which we're going to keep just as the positive 9. And that's your answer. You can't simplify it any further. And finally, the last one, simplify. We have four terms here, but interestingly enough, in this question, none of them are like terms. So we're just going to collect the first term, which is your x squareds. And then given that both of these terms have a degree of 1, the next thing that would determine which one we put first will be alphabetical order of variables. Since x comes before y alphabetically, we're going to put this as our second term. This is our third term. And that is our final term. Question 13 says find the difference, and we learned that the easiest way is to use the keep, flip, change. Just like when we did this question in grade 7, we keep the first change to addition, and use the opposite. That will give you the answer of positive 5. So because this worked well in grade 7, we can apply the same logic to polynomials. We're going to keep the first polynomial, in this case a binomial. We're going to change it to addition, and we're going to use the opposite of every term in the second polynomial. So instead of a negative 2x, it's a positive 2x. Instead of a positive 3, it's a negative 3. And now that we changed it, we can gather like terms. Those two will gather to make a negative 2x. These two will gather to make a negative 8, and that is the difference, or the answer, to that question. Again, same logic with the next one. Keep the first polynomial as is. In this case, it's a trinomial. Change it to addition, and use the opposite of every term in this second one. So positive 6x squared, negative 2x, positive 3. So now that we've changed it to the opposite, gather like terms. These two will form a positive 12x squared. These two will form a negative 3x. And these two will form a positive 6. So our solution to 14 is 12x squared minus 3x plus 6. Good. Question 15 is, what addition or subtraction equation could be used to find the missing polynomial, and what is it? Two parts. So because this is a sum period, we're going to take the bottom and we're going to add it to the top. This is the actual answer for what expression would we use to solve the top one. Gather like terms. These two would form a positive 3x squared. These two, there's no other x's, so a positive x stays by itself. There is no more constant, so it stays by itself. And therefore, your answer would be 3x squared plus x plus 4. In the next question, it says, what's it used? Now, remember when we solved this one before, we actually used a simpler question. If I gave you this one here and said, what number is this? Most of you would be able to tell me it's 4. And the reason why we got that, is this take away this told me this answer. We apply that same logic to polynomials. This take away this should tell me this, or 2x squared minus 5x plus 1. Take away this term here should tell me the missing term. Because this is subtraction, we're going to keep flip change. We're going to change this to its opposite. Each term must become its opposite. Some people forget to do that. I'd scratch this out now so we don't confuse things. And now that we have it, we just have to gather like terms. 2x squared and 3x squared make 5x squared. Negative 5x and positive 4x make negative 1x, or just negative x. And the positive 1 stays by itself, and therefore that is your solution. If you're doing this in the test, double check your answer. This plus this is this. This plus this is this. This is by itself, so my answer is correct. Question 17, model to solve. We're adding, so we're just going to draw the first polynomial. This is x squared plus 4. This is negative x squared plus 2x minus 1. These are the two together. If I want to put them in brackets, you can. You don't have to, but you could. When you gather like terms, I'll use my red marker. These two make a 0 pair. They're gone. My 2x's are left. They can't be 0 paired with anything or gathered with anything. And this one make a 0 pair, leaving me with this. And therefore, my answer is 2x plus 3.